All right. So what do you guys think about this one up here? Hmm.
Like the fraction when you have to like take the inverse.
Yeah, for this example 13, I must admit, guys, at the moment I'm a little bit stuck. I'm not quite sure what to do there.
Would it be x cubed equals 64 over 343?
X cubed. Oh, hey, very good, very good. So you're like, take x to raise both sides to the x power. Perfect. So x to this is equal to x to that, right? But x and log base x are inverse functions. Perfect, perfect. Exponentiate both sides base x. If I do that, this gives me 64 over 343 equals to x cubed. Very good. And then that I can solve by taking the cube root of both sides. So this tells me then that x is equal to the third root of 64 over 343. And 64 is 4 cubed. 343 is something else cubed. I think it's 7 cubed, right? So this is actually 4/7. Thank you. Left to my own devices, I would have found a way to make that way more complicated. So, and then about 10 minutes later, I would have come back to, oh, duh, just take both sides to the x. All right, so then next up here, how about this one? Oops. While you guys are chewing on that one, let me write up the next one here. Example 15. This one's more of a simplification problem. We're just supposed to do log base 10 of 11x over 5, and we're told to simplify. It says use properties of logarithms to rewrite the following expression as a sum or difference of logarithms, each of which is the logarithm of an integer or a variable. I'll assume all variables represent positive real numbers. This is number 31 in the homework, example 15. These two were like high 20s. So what do I do here? I think I just need to simplify this basically, right? How do you calculate log base 49 of the 9th root of 7? Well, if I could change this to a 49, then we'd be in business, right? Because if the bases match, then we know what to do. We know that log base 49 of 49 to stuff equals stuff, right? Whatever that stuff is. How do you change a 7 to a 49? This is that trick we did in the factoring, right? This is the square root of 49, right? The 9th root of that. Right? 7 is the square root of 49. And so what you're really looking at there is 49 to the 1/2 power raised to the 1/9 power. Right? Because remember, 9th root means means the 9th 1 over 9th power, yeah? So what we have is we've got log 49 of 49 to the 1/18th power, which is, by the way, equal to 1 over 18. And there's your solution. Now, is there another way we could have done this one? Like, suppose you don't see this really kind of sneaky step I just made. Could we do this problem a different way? I think we could. So like this log 49, of, so we've got log 49 of 7 to the 1/9 power, right? Right? So this is really 1/9 log base 49 of 7. So you could do that, and then maybe that would, if you think about this, right? We have I mean, maybe this is an identity worth putting on your sheet, right? Log base a of the square root of a, what's that equal to? So we've got a to the 1/2 power, right? So this is 1/2. So this is an identity worth adding to your formula sheet, because then when you run up against something like this, you're like, oh, so this is a equals to 49, and that's the square root of 49. So this is equal to 1/2, you know? So I don't know, maybe is that easier? I'm not sure that's easier, but there it is anyway. Let's move on to actually easier problems. How do you, example 15, simplify? Now you guys, you can jump in and ask questions at any point. Like, you know, I'm just kind of running through the homework here, hitting problem after problem after problem for you. That is how we learn these things. So look, what I have here is I've got log base 10 of 11x, yeah, minus log base 10 of 5. The instructions to this problem say to simplify it so that you're either having a log of a variable or an integer. So I'm not done yet, see, because I'm not allowed to have 11 times x in my answer. So one more step. This is going to be log 10 of 11 plus log of base 10 of x minus log base 10 of 5. And so this right here would be a simplification of the given logarithm according to the instructions given in the problem. There is a ginormous difference between example 15 and the other examples we've done so far today, which is what? This is an expression. We're simplifying an expression, right? So this would be to polynomials as like polynomial factoring is to polynomials, right? Factoring, the answer is an expression, right? We also have polynomial equations where the answers are numbers, right? We've been working equations up to this point. The next bunch of problems are expressions. They're simplifications. So the answer is not a number. The answer is an expression again. There's another one here that goes the other way. So here they start with it expanded. 3 log base 4 of x minus 2 log base 4 of y. And you're asked to put it together in the log of a single thing. Yep.
Why do you have to separate the 11x?
The instructions to the problem. So the instructions to problem 31 in the homework. This is number 31, I believe. Let me look back here. Yeah, 31. It says I'll read it. Use properties of logarithms to rewrite the following expression as a sum or difference of logarithms, each of which is the logarithm of an integer or a variable. So my answer has to be logarithms of integers or variables. This is the log of an integer. That's the log of an integer. This is the log of a variable. But this would be an integer times a variable, which is, you know, not, the instructions want you to simplify this expression in terms of logs of integers or variables, and that's what we have. You know, simplification is always more subjective, right? Because the question is, what's simple? Right? You might say that 11x, my initial thing, log base 10 of 11x minus log base 10 of 5 is more simple, right? And I wouldn't disagree, but, you know. So, okay, so let's see here. I want to write this as a log of a single thing. So I'll do 2 steps. Step 1, this is log base 4 of x to the power 3, right? Using the power property for the logarithm over there. And let me erase. I don't think I need this here. Oh man, look at that. This board. Yarr. So that's the first term. How about the second term? What you got? Plus what? Or I should say, yeah, plus log base 4, or excuse me, my bad, minus log base 4, I'll bring the 2 in, but not the minus, log base 4 of y squared, okay? And then put them together, we've got log base 4 of x cubed over y squared. And so this is, you know, the example 15, which is like number 31 in your homework from this module, it's to expand the logarithm, right? This one is to collapse into a single logarithm. So we have expanding, and collapsing. They're different, but obviously both of them are how do we do both of these things? Both of them just require us to understand the laws of logarithms and to apply them, right? All right. So I hope that is enough to get you started on those. So the other thing I should talk about today that I have not yet talked about, we don't have a lot of time, unfortunately, but so is how to convert from one base to another. So, you know, change a base, let's say. So to start with, let me talk about how you can change. We can take, you know, a to the power x, and we can write it as e to the power y for what choice of y. Like if you want to rewrite a to something as e to something, how would you do it? Well, let me just solve it. So to solve for I'm going to try to find out what y is in terms of x. I take the natural log of both sides. Natural log of e to the y, well, that's just y again, right? So what this tells me then is that a to the x is equal to e to the, you know, natural log of a to the x. Can you guys tell me how to simplify natural log of a to the x? Well, x is the power there, right? We can pull it out. And what we have then is e to the x times the natural log of a. So there it is. There's the trick. We can rewrite e to the x as e to the x natural log of a. This is it's a very handy trick. Let me apply it to an example, 17. If I have 2 to the x, I can rewrite that as e to the x times the natural log of 2. So I can repackage 2 to the x as an e to the x, but it's not just x, it's natural log of 2 times x, okay? And then finally, the other thing we should know about is the change of base formula for logarithms, because most of your calculators, if you look at like log base, try to find log base, you know, 3 on your calculator. It's not easy to find if it's there, but there's a way to change logarithm from one base to another, and here's it is. So if I have log base a of x, we can rewrite that as the natural log of x over the natural log of a. All right. It is more generally true that it's log base b of x over log base b of a. I mean, that's also true, but as an application here, example 18, our final example for today, if I want to calculate log base 3 of 7, I can do natural log of 7 divided by the natural log of 3. And so if you have a calculator which has natural log on it, you can calculate log of any number, any base, just by using the change of base formula. So like here, you know, natural log of 7 divided by natural log of 3. What do I get? I get, you know, it's a complicated decimal number, but it's 1.771-ish. So there's that. Anyway, have a good weekend, you guys. I see. What's that?
If we did that on our calculators and we gave you a decimal point, would you do that?
I would take that. It depends on, some questions require exact answers, so it kind of depends on the question. But And there are some places where